Hello everyone, welcome to our Patashala's video archives on YouTube with an aim to assist you master the skills of SRE and DevOps in AWS. This video is part of our Patashala's video series on various components or services on AWS cloud. So let's get started.
In the previous video of this video series,
we were looking on what scaling out and scaling in means. Today we would be looking at how scaling out and scaling in is performed manually on AWS. For this, we would need a load balancer as we were discussing in the previous video. The load balancer would act as a gateway which would distribute the load across multiple servers when we keep adding them behind the device. So we would quickly be creating a classical load balancer which is soon to be deprecated. I would be giving a name to the load balancer. We are going to create a public load balancer and we would be selecting this subnets which would give us the public load balancer. I'll be using an existing security group which is allowing traffic from the internet. We'll be changing the interval to 6, the healthy threshold to 3, so that we could have our instances quickly. We don't have any EC2s yet, so we have not added any of the EC2 instances here, but we will be providing all the details and creating the load balancer as we speak. Now the load balancer has been created. Let's quickly create some EC2 instances. We could opt into the new experience of creating the EC2 instance. I'll name this as web SRV and I'll put it in 1A. We would be selecting the instance type as 1 CPU, 1 GB of memory, which should be enough. I'll be editing the settings and I would be selecting the private subnet 1A so that we could have the EC2 instance there. I'll select an existing security group for this, which would be this, and I would be adding the advanced details. In the advanced details, we would be adding user data, which would help us get the instance started with the web server configured into it automatically. We'll quickly launch the instance and monitor the progress. Now that we have launched the EC2 instance, we should also be adding the EC2 instance behind the load balancer. So once the EC2 instance has been added behind the load balancer, we would then have to wait for this to come to in service. In the meantime, we could also be checking the logs of the EC2 instance that is being provisioned at the moment. The log should be appearing on the system log screen under monitoring section of the instance. So as you guys see, the instance has already come into in service. What we can now do is access our application using the URL. So I'll put the load balancer details in the system, the URL, and I should be able to get the website posted on this. Now, in order to manually scale out, right, we would have to first create the EC2 instance. We would have to create a new EC2 instance on this load. In order to scale out manually, right, we would have to create a new EC2 instance and then assign it behind the load balancer manually. So let's quickly create our EC2 instance, and I'll be selecting the same details almost all. We would be doing a slight differentiation with the user data. wherein I would say this is coming from server 2. This is just to give you a perspective from exactly where which server is being shown. I'll also be changing my subnet to the private subnet. This is to make sure that this gets created in the private subnet and not in the public subnet as intended. While this is being created, let's also create a new EC2 instance, and we can call it CBP00. Whereas we one, I'll say it 1A2. This is the third EC2 instance that we are creating, and we would keep this in the private subnet 1B, and we would assign an existing security group, which would be this, and then adding in the user data. And this time in the user data, we would call this from server 3. I'll also launch this EC2 instance. Now, if you see in the instances tab, we only would be having one EC2 instance. So I would be going in and adding the new EC2 instance, which is 1B. And we would have to wait for this EC2 instance to come in service before we are able to access the traffic from the second server as well. Now, this kind of addition is generally done to have a higher availability of the application, to make sure that if any one availability zone goes down, the application is still accessible from the second availability zone. The other reasons could be if there is huge load that we are going to anticipate on the website, we could provision the servers in such a way that it could handle the website traffic in a better way. So now if you see, the load is being distributed from server 1 as well as server 2. In the same way, we could add another server, and this would give us all the three EC2 instances. So the load would be distributed. So the load would be distributed between three EC2 instances, like we see, like we saw in case of two EC2 instances coming in service. So we'll just quickly wait for the service to come. We will wait for the server to come in service, and once it comes into in service, we should be able to access the website from the third server as well. So as you see, we are able to see the request from the third server, and it's being, with every refresh, it's actually hopping into different EC2 nodes, and we are able to access the server. So this was scaling out manually, and what if we had to scale in automatically? What if we had to do a scale in or reduce the number of servers back to 1? So there are two ways in which this is generally done. I would quickly go to the EC2 dashboard to get the running instances. What we could do is we could terminate one of the instances or stop one of the instances. So once I stop the instance, this EC2 instance would go out of service behind the load balancer, and the server would come out of the existing traffic. So the traffic would not be sent to the second load balancer because it's out of service. But in this scenario, we are not saving any costs due to stopping, right? Because the disk and the other usages are still being used. So in ideal scenarios, it's always best interest to terminate the instance. And once you terminate the instance, the server should automatically be delisted from the load balancers very soon. Now, if the servers are not coming out of the load balancer due to some reason, you could always remove them from the load balancer. The other way is simply removing the load balancer from the service, and we are only left with one load balancer. So if in case in future we still need the second server to be coming in, we could still add it. But if we think that the server is not needed and we can live without, we can live with only one EC2 instance, we could also go ahead and terminate the other instance. So now that I terminate this instance, you would see that once this instance goes to terminated state, we should also be looking at the load balancer, where this would automatically be removed from the load balancers instances. So this was scaling out and scaling in manually on Amazon Web Services using a classical load balancer. We have a similar concept with both application load balancers as well as network load balancers. They being more trickier because of some additional components that gets added to them. That's it for this video. I hope you like the content on this. If so, please like the video and share it across with your colleagues. Thank you so much for watching. If you're not subscribed to the channel, please subscribe. And I hope you keep having a good day.